Now in this video, we're going to revisit Euclid Book 2, proposition number 4, and there's a very good reason for that. We have a quadratic formula right up here, and it says x squared equals y squared plus 2yz plus z squared. Now how do we know all this is true? Well, the only way we know this is true is if we replaced x here with y plus z. And that's what we've done right here. Instead of saying x squared, we're now going to say y plus z squared. Now, hopefully you remember the FOIL method of mathematics, because y times y is y squared. Yz plus yz equals 2yz, and z times z equals z squared. And that's how this comes to be. So therefore, x squared equals y squared plus 2yz plus z squared. Now, that's how you represent it algebraically, but how do you represent it geometrically? Well, Euclid gave this to you in Euclid Book 2, proposition number 4. Okay? Now, let's take a look at the x square here. We're going to take this one step at a time. The x square in this particular case is AB. Okay, the length of AB squared is x squared. Now we said that x equals y plus z. Well, what's the length of y and what's the length of z? The length of y is AC. The length of z is CB. Okay? So, we're literally taking the length of AC and the length of CB, and what we're going to do is, instead of saying all this up here, what we're going to do instead is we're going to say the length of AB squared equals AC squared plus twice the distance of AC times CB plus CB squared. That's right. So we're going to take actual lengths from this equation over here, right, from this actual diagram right here. We're going to take actual length from this diagram and then translate it to this. And that's how we'll come up with AB, here, let me get my marker out of the way, AB squared equaling AC squared plus 2 times AC times CB plus CB squared. Now let me show you AC squared and CB squared. Okay. Here is AC squared. What we did was we took the length of AC and we drew it 4 times. Here, 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 and here. Now, if you'll remember, rectangles, the area of rectangles are found by taking the length times the width. Well, in this case, the length times the width is exactly the same. So if you take the length of AC times the width of AC together, multiply them together, you're going to get a square area. That's why they call them square areas. Alright, so what about CB? Well, here's the length of CB and here's the width of CB. And like I said, all 4 of these sides are the length of CB. So length times width, you get a square area here. Okay? Now, we also said 2 times AC times CB. Okay. We already know that the length of CB is exactly the same as the length of CG. So, instead of saying ACCG, we can say ACCB. So, we have 2 rectangles. This rectangle is the same size as this rectangle. So, twice the area of these 2 rectangles, okay, plus the area of this square plus the area of this square gives you the area of ABED. which is what you were looking for. Okay? So basically, since AB here and BE are exactly the same length, then you can say AB squared. Alright? And hopefully that cleared it up for you. If it didn't, you let me know. I will tell you more in a future video, so stay tuned.